Okay, this problem was really the most fundamental problem we can do about a wave. We were told that a wave has a 10 centimeter wavelength. So what does that mean? Well, what that means is that if you were to graph the displacement as a function of space, for example, then you might have a wave that looks like this, where it repeats in 10 centimeters. So this is the wavelength. We were also told that it has a frequency of 2 hertz. So what that means is that if we make the snapshot graph, say maybe it looks like this, what that means is that the time that it takes for any point on the wave to make one complete cycle, so this again is a snapshot graph for any one spot on the wave. Now what we know is that the period is half a second. And we know that because the frequency is 1 over the period, and we were given that it's 2 hertz. Therefore, the period must be 1/2. Okay, so that means that we can write the equation for the wave. So we know that y is equal to a sine or cosine. I like cosine, but it doesn't really matter, of kx minus omega t plus phi, where k is 2 pi over lambda. So this is 2 pi over 10, and the units here would be radians per centimeter, or maybe just inverse centimeters, since radians not really a real unit there. And the omega is 2 pi times the frequency, which is 4 pi radians per second. Okay, so that means that, well, we can just write that into the equation here, and we can write that y is a, so let's see, is whatever the amplitude is. We weren't actually given the amplitude. Cosine of, let's see, 2 pi over 10 is pi over 5 inverse centimeters times x minus 4 pi inverse seconds times t plus phi. We also weren't given the starting conditions. And that's it. That's the equation of the wave. So we've sketched it, we've written the equation, and now we notice that the speed of the wave is the wavelength times the frequency, which is wavelength is 10 centimeters, and the frequency is 2 hertz. So let's see. So the wavelength times the frequency is equal to 20 centimeters per second. And that's the speed. We can also notice actually that the speed here is omega over k, which is 4 pi divided by 2 pi over 10, which is the same thing as, let's see, 40 divided by 2, the pi's cancel, which is again just 20 centimeters per second, the same thing. Okay, that's it.